Continuing lesson 8.3, which is on displaying data in box plots. We'll look at the Do You Know How number 4. This is on page 470. Page 470. So we have some test scores. Sarah's test scores are listed there, and they're asking first of all what are the minimum and maximum test scores. If you look at the next questions they're asking us, we are going to be drawing a box plot, finding the median, all these things. So I'm just going to go ahead and I put the numbers in order here from least to greatest. Okay, numbers least to greatest, and then I can very easily see that my minimum test score is 73 and maximum is 90. Okay, so minimum 73, maximum of 90. And then the next question, they want us to find the median. So to find the median, we need to look how many numbers we have here first of all. 9 numbers, is that correct?
Yep.
Okay, 9 numbers, I definitely have a middle number, right?
Yes.
So which one is my definitely middle number here?
It would be 79.
79,
yeah,
good.
I skipped. I forgot to read the 85 and 78. And so I erased the 79 because without that it would still be 79. And then I figured I could just have it there.
Okay, so 79 is our median. And then the next question, they want us to find the first quartile and the third quartile. So first quartile is the median of the numbers below the median. So these numbers are the ones below the median here. If you'll notice, that's 4 numbers below the median. So do we have a definite middle number? No, we have 2 middle numbers. So 2 middle numbers are 75 and 78. So we're going to have to average those out. So you can add those together and divide those by 2. If you want to do that as one step, you can. If you want to do it as separate steps. Okay. And if you do that, you should get 76 and 5/10 or 76 and a half would be our first quartile or lower quartile. And then we'll be doing something similar for our upper quartile. Upper quartile as well, we have 4 numbers up here, so we have 2 middle numbers would be the 82 and 85, so we're going to average those out. Again, if you can see what's exactly halfway between 82 and 85, you can do that, but otherwise add those and divide by 2.
It would be 83.5.
Good. So 83.5 would be our third quartile or upper quartile. Okay. A way you could think of, I guess, third quartile, it's kind of like really, I guess it's like the end of the third quarter and the beginning of the fourth quarter is a way of looking at that. So these are the numbers we're going to be working with, and then they want us to draw a box plot. So the box plot, we're going to be using those 5 values that we just talked about: minimum, maximum, median, first quartile, and third quartile. So to do that, you may want to go by 1s or 2s, or you could go by something bigger than that. The bad thing is, if you go by bigger intervals, it's going to be harder to tell where your numbers are. The book chose to go by 5s. I'm not a big fan of that. The one thing about it you could do if you wanted to go by 5s, it'd be that you could mark individual lines in between the 70 and 75, in between the 75 and 80, and so on.
That's the same by going by one.
That would be like going by ones, but not having to write all the numbers of going by ones. One thing about this, normally they're not going to do this, but on your box plot, if the numbers are not very nice, like these, we had some decimals that came out here. If you do something like this, just to kind of clarify a little bit of what exactly these points are. You know, this was supposed to be 73 here, this was supposed to be 79 here. Okay, we're not going to draw those lines that I just drew there, but you know, that's where those are. And then the last one's at 90, but you know, just to kind of clarify so everybody knows exactly what those numbers are, doing something like that is probably not a terrible idea. Look at number 8. Eric is in Sarah's class. This box plot shows his scores on the same 9 tests. How do Eric's scores compare to Sarah's? What we can do is kind of just look at some of these points along the way. First of all, we might be interested looking at what their lowest and highest scores were. So you can see Eric's lowest score was a 70, which is lower than Sarah's lowest test score. So we could say his lowest test score was lower than Sarah's. If we look at the highest test scores, both 90s, aren't they? Okay, so they both had the same highest test score, which is 90. We could also look at the median. So the median for Sarah is about, what did we say, 79. And Eric looks like 85. So, in other words, half the time, depending how you want to look at this, half the time Sarah got lower than a 79, half the time she got higher than a 79. Eric, half the time he got lower than an 85, half the time he got higher than an 85. So you might, based off of that, since Eric has the higher median, you might say that in general, Eric has done a little bit better on some of the tests than what Sarah has done. The book is going to talk about the first quartile and third quartile here as well, so I'll just show you what they've got. Eric's minimum score is lower than Sarah's. The maximum scores are the same. We already talked about Eric's first quartile, median, and third quartile scores are higher than Sarah's. Okay, so again, just some different things we can look at, kind of make some observations, and this is called analyzing or comparing these box plots or box and whisker plots. Looking on workbook page 113, pretty big numbers on number 1 with the bowling scores, so we're going to look at number 2 as a little bit more normal numbers maybe for us to work with. So first of all, ultimately we're going to be doing a box plot, but we need to find a median. So finding the median, I need to put the numbers in order. So we'll go ahead and put them in order here. When you put numbers in order like this, I suggest that you cross the numbers out so you can keep track of what you've done. I'm sure you've done this before a couple of times. Okay, so we'll put them in order, then we'll look and see what our median is here. And it looks like we've got 9 numbers, is that correct? So with 9 numbers, we have a definite middle number, which would be this first 8 here. And we don't have to, when we say the median is 8, we don't have to specify it's the first 8, but that is what it is, and that's going to be important whether it's the first 8 or the second 8 for our next part, which is what is the first quartile. So for the first quartile, we're looking at the numbers below the median. A 6 and 3/7 here. That's 4 numbers, so we have 2 middle numbers, which would be the 7s here. So if you think about it, if you average out 7 and 7, you're going to get 7. You can work that out if you'd like. It's going to be 14 divided by 2 is 7. So if the numbers are the same, it's always going to be that number. Then we'll look at the third quartile. So third quartile, we're looking at the numbers above the median. We have 4 numbers once again. Gives us 2 middle numbers, 9 and 10. So we're going to average those out. So add those together and divide by 2. Or if you can think about what's halfway between 9 and 10, would be 9.5 or 9 5/10. Okay, so now we've got our key numbers that we need to work with, so we are ready to draw a box plot. So drawing a box plot, you can see our numbers are going to go from 6 to 10, and we do have one number that doesn't come out as nicely here. So I'm going to try to just space my numbers out here a little bit. And I probably didn't need quite as big of a line. Okay, so if you can equally space your numbers on your number line, it is a line, so you can put arrows on the ends of that. Okay, so I guess, you know, the ideal way of doing that would be if you use a ruler, maybe make an inch or a ½ inch or whatever, a consistent interval in between the numbers. So 6 is the smallest number, 10 is the biggest number. First quartile is 7. So if we go from our minimum number to our first quartile, that's going to be our first whisker. Goes from 6 to 7. Our median is 8, so that means our first box is going to go from 7 to 8. Third quartile is 9 5/10 or 9.5, so that means this box is going to go from 8 to 9.5. Okay, and my numbers are spread out here enough that I can probably just tell that that's 9.5. And then we're going to have last whisker goes from 9.5 to 10. Part E, they want us to write 2 conclusions about the data. So this doesn't have to be any kind of amazing things that we're coming up with here. Okay, just some observations is fine. So here's some things I noticed. Sabrina's median score is 8. Her lowest score is 6. Her highest score is 10. Half of her scores were below 8 and half were above 8. Okay, you can mention what the first quartile was, what the third quartile was, but these are kind of some key things that, you know, we said about 3 or 4 things there without having to think a whole lot about what's going on here. So this is over on workbook page 114. We're going to look at numbers 9 and 10. So number 9 asks, how much does the less expensive 50% of trail mix cost? The less expensive 50%. So remember, these box plots or box and whisker plots, each section is 25%. So if we look at our median is right where the boxes intersect each other, if you want to think of that as 2 boxes in the middle. So that's basically at our 50% part. 50% or half of the trail mix is cheaper than this, half is more expensive than that. So the least expensive 50% costs between what? $1 to $3. Good. So you could say the less expensive 50% costs between $1 and $3. Okay. Again, that's kind of just making an observation there based off of the median. So that's number 9. We look at number 10. How much does the most expensive sandwich cost? So most expensive sandwich looks like would be what? $7.50. Good. Now here's the marks here. Maybe a little hard to tell exactly what's what, but there's that point. That looks like the 7 and the 8 there, so we're halfway between. So $7.50. And again, anytime we're answering these, probably doing a complete sentence would be a good idea. Most expensive sandwich costs $7.50. Just for time's sake, I'm not going to type that all up here though.